Human in the AI Loop by Christos Emmanouilidis. And the way we would like to proceed here is that I'll first introduce Dash to those in the audience that do not already know Dash. And if I look at the names, then there might be a few. And then I would like to hand over the floor to Christos to present for us his webinar. During the webinar, I would like to ask you to save up any questions you might have to Christos, either put them in the chat or save them for after the presentation, so that we can have the presentation first and then the discussion. So to start off, first of all, I would like to introduce Dash. Dash is the Data Science Center in Health of the University Medical Center Groningen. It was established nearly 5 years ago, recognizing that data science increasingly was becoming an important enabler for research, education, but also care and innovation. Dash was established, and we have recently phrased our goal as embedding data science in the DNA of the 𝐜𝐭. Oh, somebody's flipping through the slides quickly there. I didn't realize that other people could do that, sorry. So our vision in the long run is from Dash is to for the 𝐜𝐭 to be an international leader in data-driven healthcare innovation, and it is something that we're going to achieve both in our own organization, but of course also a lot through our partnerships in the region, in international context, and not just focused on research, but also on healthcare and innovation. The reason why, well, I think over the past year, data science and AI have been very much in the public view. But we have, of course, already for a longer time realized that data-driven innovation can really enable us, drive us to deliver new and innovative tools to build the future of health. The way we work as Dash, we have a number of key areas that we work on, our areas of expertise, which is machine learning, clinical applications of AI, clinical cohort data, and e-health. And we identified a number of activities that we could do to support bringing this expertise into practice. First of all, by our collaborations incubator, developing collaborations or supporting applications, project support, how to implement AI, educational activities. We've, for instance, also developed a really nice, massive online open course on AI in healthcare. Impact and outreach, so communicate about our activities and how we see AI bring value or data science bring value, and in that way promote the use, and of course funding opportunities. And these activities, of course, require certain facilities or infrastructure. So what we also have is an AI think tank, a group of colleagues that think ahead, what is coming, what future applications do we see. We have a machine learning lab, which is, first of all, a really large community of colleagues that have a data science interest and typically also practical activities related to it. And within the machine learning lab, a lot of ideas, a lot of tools, a lot of ways of working are exchanged. And it's also nice to have colleagues to which you can on which you can fall back in case you have any questions, etc. Then we have the 𝐜𝐨 Lab Northern Netherlands. This is a lab that is focused on developing frameworks of ethical, legal, and societal aspects of data science and AI in health, and how we can properly use it without being stuck on constraints of, let's say, privacy, but finding ways to effectively work within those contexts. And then we have the IT lab, where we develop innovative infrastructure that really the front runners of AI can use new tools to make sure that we facilitate them. And last but not least, it's our communities, of which the machine learning lab is an example, but there are more. So that is the way we've been organized. Our 4 levels of expertise are also spearheaded by a scientist. And so the machine learning lab is spearheaded by Peter van Ooyen, clinical applications of AI by our orthopedic surgeon Job Doornberg, clinical coordinator by radiologist Rosemarijn Vliegendhart, and our researcher eHealth is Esther Metting. So that's the brief introduction on Dash, and if you have any questions, comments, or would like to connect with Dash, please be aware that I will show a QR code in the end that you can apply for our newsletter, but you can also just scribble a short email with your interest to dash@umcg.nl. So that should be easy enough to remember. So once again, on the presentation now, please keep your mics muted. If you have questions, it says here raise your hand, but please save them for later, put them in the chat, or save them to ask after the presentation by Christos. And with that said, I want to introduce our speaker of today. So Christos is an associate professor at the Faculty of Economics and Business at the University of Groningen. He has had multiple principal investigator roles for projects related to AI and cognitive systems, robotics and automation, human in the loop with linked data and knowledge, as well as cyber-physical systems and Internet of Things technologies to serve industrial applications needs, carrying over 20 years of experience in positions in business, academia, and organizations supporting research and innovation. So, Christos, may I give the floor to you?
Bart, thank you very much for the kind introduction, and many thanks to DAS for inviting me to join the DAS community, and especially thanks to all those connecting for this webinar. Let's start by making the slides available to start with. So I will share first. Let me do that. Hopefully it works. Is it visible?
Yes, we can see your slides now.
Very good. So I'm quite happy to be part of this webinar series and share some ideas and thoughts about synergies between human and AI. The motivation for the talk is a little bit related to the discussion and the debate about the use of AI in practical everyday situations, especially with AI replacing of humans in many situations. So I would like to take the opportunity to make the case for placing the human in the loop, because in many cases it's much better. We are much better off having best of both. That means humans and AI working in synergy, rather than only humans or AI only. So that will be the context of the presentation. I don't think I will repeat my presentation because Bart has already offered that. So I will just leave that for reference for the slides. And I will move on straight away to the presentation. So I would like to start with the motivation for this talk, this discussion, I would say, after the talk. Then after presenting the motivation, I would like to share with you some thoughts about human and AI synergies. And that will be followed by some practical exams and cases. These will be primarily from one of the three European projects that are listed here, the STAR project, which is about safe and trusted human-centric AI for manufacturing, which is in the third year now, but two more projects are starting. The Humane project has just started, and it is about hybrid human AI decision support for enhanced human empowerment in dynamic situations. The interesting thing there is that this project is not just about manufacturing, but it is about the frontiers of the decision making between humans and AI in various applications, including healthcare, I'm pleased to say. And the final one is about the AI for Work project, which is about the impact of AI on work environment. So this project starts at the beginning of next year, also an Horizon Europe project. Well, starting with the motivation, let's see some thoughts expressed by humans, not AI. What about the city of tomorrow? I think it will be completely different. In fact, it may not exist at all. Oh, I'm not thinking about the atom bomb or the next Stone Age. I'm talking about the incredible breakthrough which has been made possible by developments in communications. In fact, almost any executive skill, any administrative skill, even any physical skill could be made independent of a distance. I'm perfectly serious when I suggest that one day we may have brain surgeons operating our patients in New Zealand. Now, is that a recent guess? Not so much. It's from an Arthur Clarke interview many decades ago, back in the 1960s. And you will recognize that some of the things mentioned there, well, I don't know about the brain surgeons yet, we're not there yet, I guess, but the technologies are there to enable working from distance. And sadly or happily, whichever way you put it, at least in the COVID times, we experienced a lot of remote working. We were pressed to do that. Some of it still remains in place. But that motivates some of the thoughts that we will be discussing today. But the next one I want to share with you is this. Back in 2019, the OECD made a bold forecast. Within the next 15 to 20 years, it is predicted that new automation technologies will likely eliminate 14% of the world's jobs and radically transform another 32%. Those were sobering numbers involving more than 1 billion people globally. And they didn't even factor ChatGPT and the new way of generative AI that has recently taken the market by storm. The average half-life of skills is now less than 5 years, and in some technology fields, it's as low as 2.5 years. For millions of workers, upskilling alone won't be enough. Reskilling programs require participants to make a major investment of time. So it's important to try to reduce the risk, cost, and effort involved for that. Well, that's not something that has been expressed far in the past. It's the latest issue of Harvard Business Review under the theme Reskilling in the Age of AI. Another one, employers anticipate a structural labor market churn of 23% of jobs in the next 5 years. This can be interpreted as an aggregate measure of disruption, constituting a mixture of emerging jobs added and declining jobs eliminated. Within technology adoption, big data, cloud, and AI feature highly on likelihood of adoption. More than 75% of companies are looking to adopt these technologies in the next 5 years. Now, the second ranked technology encompasses education and workforce technology, so the training of people, with 81% of companies looking to adopt these technologies by 2027. The adoption of robots, power storage technology, and distributed ledger technologies, blockchain if you like, rank lower on the list. And this is from the World Economic Forum, the current Future of Jobs report. And that also includes the observations that analytical thinking and creative thinking remain the most important skills for workers currently. Cognitive skills of workers are reported to be growing in importance most quickly, reflecting the increasing importance of complex problem solving in the workplace. However, the skills that companies report to be increasing in importance the most are not always reflected in corporate upskilling strategies. Again, from the same report. Now, in the same report, an observation is made that the human-machine frontier has shifted. Part of the observation is actually that the introduction of automation comes to slightly lower pace than previously anticipated. Task automation in a few years' time is expected to vary from 35% regarding reasoning and decision making, which is of interest for us today, but much higher for information and data processing, which have reached a much higher level of maturity. So while expectations for the displacement of physical and manual work by machines have somewhat decreased, reasoning, communicating, and coordinating, all traits with comparative advantage for humans, are expected to be more automatable in the future. I highlight this word because it's ambiguous. It doesn't say that it will be fully automated, and I would like us to discuss this a little bit while we progress with the presentation and the discussion. Now, artificial intelligence, a key driver of potential algorithmic displacement, is expected to be adopted by nearly 3/4 of surveyed companies and is expected to lead to a high churn, with 50% of organizations expecting it to create job growth and half of them expecting to create job losses. It might sound like a contradiction, is it? Here is another example. My family used to do a lot of the work manually, but now all is done by robots. When I speak to them, they seem bored. Money is good in the job, but my family has nothing really to do. They watch, and you can place any TV streaming service here. They watch that streaming service all day. So I know robots make things easier, but I'm not sure it is always better. So this is a dialogue between two persons. Look, robots do a lot of things better than we can. Look at the number of new drugs machines have discovered. Why would we want to prevent that? They, robots, write contracts, predict the outcomes of cases, and so much more that even lawyers will be out of a job soon. So, and here is the revelation that one of the discussants is a student in a law school. I study in a law school because I want to work with robots, not to be against them. So this is a fictitious dialogue, and it's been borrowed by a new book called Forever, a legal sci-fi story by Daniel Gervais. A very interesting one, which touches upon legal and ethical aspects of AI, and I would highly recommend that. So that hopefully give us enough motivation to start thinking about models of human AI synergy. And well, we can think of several such models. Here is an example. So where you have the AI designer and developer that designs the AI system, that it is part of an AI-enabled physical system. And then a human person, a human being, a decision maker that is fed the outcomes of this AI-enabled system and makes a decision incorporating a body of expert knowledge. And then let's say that the outcome of that feds into the society. Then there is impact on the society. This is very abstract. But since I'm in DAS and in this environment, I thought of making it a bit relevant, although I'm not a medical expert at all, of how this example looks into the medical domain. So human assistance example in the medical domain. So I guess some of you also have expertise in, if I understand, in radiology or things like that. So here is an example of a screen of computer system that works with imaging technologies, but it doesn't just simply show images, but it superimposes their explanations, interpretations, have different visual metaphors to make the interaction with the human user, I guess a clinician, easier, so that AI systems support humans in making decisions. And that's something that is there today, not only in the medical domain, also in other domains. But some studies indicate that this is not enough. So here is another example, again from the medical domain, a study that determines after some experiments that their worker is not sufficiently happy with what is on offer. So they say that our work focuses on sepsis diagnosis, which is a high uncertainty, high stakes, time-sensitive medical decision-making process. So the traditional linear process would be to generate a hypothesis, have some data, test the hypothesis, make final decisions, and we have some support from AI, but then you have the AI offer diagnosis, you have the medical person doing a diagnostics, and it's a kind of competition between what the intuition of the clinician might say and what the evidence or the interpretation of the evidence by the AI system might offer. So the researchers in this case propose to involve the human in the loop. And this is a reformulated process that includes actually several cycles, although they are depicted here in 4 figures. They're not that static. It's, yes, generating predictions for the patient's sepsis onset possibility, so kind of a risk score, but that prospectively also now and in the future. That's step 1. And then gather further additional lab tests that clinicians may gather to support their decision, and the interactive visualization can help them select most valuable sets. So this is an interactive process, actually. It's not so linear or not static. So there is a lot of interaction supported here. So once data collected, the prediction visualization will be updated. And the way to interpret that prediction visualization is that actually the active selection of data and relevant cases by the human user also feeds into the training process for any algorithms, or bias the training towards these relevant data. So this is some form of active learning that we also employ in the STAR project, but for very different purposes. And then clinicians can generate new hypotheses or reach final decisions. Now, another study look at the synergies between AI and humans, between machine and humans in simple cases. In this case, a simple task relevant to kind of arcade game, and they wanted to investigate the performance under different scenarios. So humans competing with each other, humans collaborating with each other, human and machines competing, and human and machines collaborating. And what you see there at the right side is the kind of, let's say, distribution of positive outcomes, so to speak. And when you see the area to be wider at the top, that means that you have a higher performance there. And in most cases, the human machine and the human collaborative performance was better than the individual performance or the performance under competition terms, which is something that is valuable to take on board in terms of human AI synergies. Now, a key concept here is the concept of affordances, action affordances. Affordances affordance is a term that knows action possibilities provided to an actor, a human or a non-human actor, by the environment. And the important message here is that the action affordances in situations of human AI interaction expand. So humans have many more action possibilities with the help of AI, and actually something that it is less well explored, AI also can have more possibilities to expand its knowledge or focus its knowledge with interaction with humans. Concepts about context and situation awareness are relevant here. But what is particularly relevant is to understand that this is not a static synergy. It's not simply that the AI is helping humans one way or humans help the AI one way. It's a dynamic collaboration, and a dynamic activity has emergent outcomes, which are not available at the scenario of static synergies between them in the scenarios of augmentation of assistance. Why that has become important? Well, it has become important because to have effective synergies between humans and AI, you have to start thinking about what humans really are, and they are cognitive creatures, and that's why what is being brought into discussion is that to make these synergies more effective, you need to think of them from the cognitive systems perspective and then think about cognitive systems architectures. I'm not going to bore you too much with them, but other than saying that work on cognitive systems architectures has been active for many, many years. So you can see different types of cognitive architectures proposed over the years, some of them based on symbols, symbolic grounding, emergent, based on, for example, memory or learning, or hybrid ones which combine both. And you can see examples of that. The Icarus architecture by Pat Langley is one of them. The ACT-R architecture is another one of them. There are many such architectures, but what is becoming very interesting now is that there is a blending of research fields here. And yes, in the last 10 years or so, we have witnessed the prevalence of deep learning architectures, and now we're witnessing the emergence of the large language models. But important researchers in the field, for example, 𝐜𝐭, who was one of the first introducers of deep learning architectures over 30 years ago, is now working on modular cognitive architectures because 𝐜𝐭 sees that this is what is really missing from current AI systems to become more effective. So they're working on modular cognitive architectures for objective-driven AI because cognitive entities like humans work towards objectives. When you ask ChatGPT about something, ChatGPT wouldn't know what are your objectives when you are asking this question? And similarly, another early researcher in the field of AI, mostly associated with introduction of decision trees, for example, Tom Dietrich, well, identifies that, for example, large language models disentangle the different cognitive functions or fail to do so, actually. So our cognitive functions are some way separate, they influence each other, but for example, the understanding of the factual world, language understanding, common sense knowledge, our ability to have memory, and particularly episodic memory, all these are kind of separate functions, and they are recognized as separate functions in cognitive architectures, but not in large language model. And that's why sometimes they don't generalize that well. They hallucinate in some cases. They say they are still extremely impressive. Only a couple of years ago, we couldn't have imagined what they have produced. But these are some of the limitations that point in the direction that effective human AI synergies come from coupling cognitive abilities of humans, possibly with kind of cognitive abilities of AI-enabled systems. And it is this understanding that puts us into the picture of trying to frame this human AI collaboration as a cognitive coupling process. So humans are pretty good at all these functions that you see on the left side about decision making, about understanding a situation, about recognizing and categorizing. Some of these are now functions that AI does very well too, but AI wouldn't be so good at generating a sequence of actions yet to meet some objectives. So the positions here is that this coupling of cognitive abilities of humans with abilities of AI-driven systems could be the way forward. And the idea there is that with human AI teaming, it is possible to expand the affordances of both human and non-human technical actors so that they can jointly have a much greater impact on socio-technical systems. And you can see some ideas, some visualization about that from our STAR project. Now, moving a little bit forward, human-machine collaboration in decision-making based on cognitive intelligence is still quite some way off. You see an example of an evolutionary roadmap. So we are quite far from cognitive intelligence of machines and AI that might feature self-learning based on AI that you see on the top right corner. And also, it is still the case that concepts such as situation awareness and shared context between humans and non-human actors is a prerequisite for effective synergies between humans and AI. I would like to move on to some practical cases and example, starting from an architecture proposed some years ago about how to jointly feed human and AI and physical entities generated events and data into a linked data and knowledge architecture.
This is an example of integrating data from measurements with domain knowledge from humans to improve machine learning. We close the data loops between different life cycle phases of an asset to add value to the data, and we visualize the outcome in a three-dimensional representation, so it is more intuitive. The domain is engineering diagnostics, but you could draw parallels also for medical diagnostics. Data are acquired from an engineering test rig. Faults are introduced to the gears. The more we move to the left, the introduced fault becomes more severe. Data are fed into machine learning to incrementally recognize situations. This helps with a sanity check about the situation, but can also be part of involving the human in the AI loop. via incremental data labeling. We often expect AI systems to produce results even when fed with data quite unlike the data seen before. This can become tricky or even dangerous in some domains. Instead, the AI, when it does not recognize the situation, can prompt the user via an active learning mechanism so that the knowledge span of the AI algorithm is increased. The user may be triggered to correct an AI outcome, to label an unknown case, and all this can be fed into the AI loop for adjusting the machine learning. Essentially, we fuse knowledge regarding the early life cycle of an asset, the 3D design representation, with knowledge from the middle of life, the operating phase. This helps both the user to understand the situation and the AI to expand its knowledge.
In the STAR project, we identified 4 different types of synergies or collaboration between human and AI. Of course, the first one is that AI takes completely over from humans. But then there are different types of synergies where AI augments humans or human augments AI in tasks, and then you can have some integrated tasks. So the first one is an example from quality control in manufacturing, where humans are engaged in labeling data for defect recognition, and then with the help of explainable AI, the AI system can retrieve similar cases. So this is a case of explainability being built a priori into the system, trying to retrieve prototypes of previous cases, but you can have explainability a posteriori that comes afterwards, after a machine learning model has been trained. So here are some examples, some more examples where a user can receive hints about quality control. So in this case, the previous case was from an automotive component, from manufacturer for parts for Volkswagen. This one is for printed logos in the Philips case. And this is also some examples of tests we did to try to understand the onset of fatigue in humans when they engage in these tasks. Physical fatigue was what workers experienced a lot in the past. Mental and cognitive fatigue will be what will probably them fatigue and in some cases bore them to, well, I wouldn't say bore them to death, but at least to become more inefficient in their tasks. So we wanted to understand that onset of physical and cognitive fatigue with these kind of experiments. And a couple more cases. So that was linked to the concept of a human digital twin in the project. So we try to understand the onset of both physical and mental fatigue. We did some experiments, as you see that, with human users interacting with a platform that humans engage into data labeling tasks or data confirmation or negation of AI outcomes, and then try to monitor and understand the onset of fatigue with this platform and the human digital twin. Another example is about human-robot coexistence in shared workspaces. And this is based on Industry 4 enabled environment at the German Center of Artificial Intelligence. So the first thing is to detect human presence and recognize the type of human activity, and then also to produce as output of the video analytics where humans actually are. I want to skip that a little bit fast because I want to move to the next quick example from the STAR project. I think I'm showing the same slide. Yeah, that's the next one. So this is an example of a shared space with a blue dot. You see there a robot moving. The arrows are humans going in workspaces. So there are two things there. The robot is actually one of many. There is a robot fleet. What you see in the middle with a blue color is a kind of a heat map. When the color is very bright, almost like white, is the goal of the robot. And the goal of the robot is part of the robot planning. But what we have done in the STAR project is to superimpose to this heat map another heat map, which is the anticipated human presence. So we predict likely human presence in these work environments, and then the robot fleet can take that into account in optimizing its planning. So that's a kind of socially aware robot path planning. So that's another example from the STAR project. And the final thing I wanted to say about the STAR project is that we also came up with an approach on how to evaluate human-centric AI in manufacturing. We have taken into account literature, but also standards about human-centered system design, and we recognize that human-centricity concepts also apply to whole organizations. Here is the summary of the process, which includes 4 steps: to define the unit of analysis, to establish a multidisciplinary team of stakeholders, have them working together to identify and validate relevant performance criteria, and then conduct the evaluation. So to do that, we did work collaboratively, both with virtual collaboration boards, as you can see here, and identify the relevant criteria, identify user needs, user requirements through user stories, identify components and functionality for the AI systems that would satisfy these components, and also have all these be mapped in the criteria. So the team that was put together is the one that brings diverse and relevant knowledge from different disciplines to anticipate the impact on the performance criteria. And that includes the necessary experts for this, so that can vary depending on the application domain. But we distinguish 3 different types of criteria. The operational ones are those that are of primary interest for the enterprise, for the company. If you ask an AI expert, the technical criteria would be very important. But if you think about work design perspective and ethics, the social and organization type of criteria are very important. So we work with workshops, physical workshops, and we fed initial ideas, and the multidisciplinary teams worked to produce a final set of criteria. I'm not going to go through them in detail in the interest of time, but they were among all the different types that we have identified. So we follow this process, and then we perform an evaluation so that we can feed forward that to the design teams. A final thought from the STAR project is that we try to take into account the process described from the IEEE on the ethically aligned design. So that includes 4 main steps: the exploration of the context of the domain and the application, the elicitation of the values that pertain to this. These are values which are relevant to the organization, to the society. So all kind of ethical values come into play, and then with the multidisciplinary team, then you define the ethical requirements, but you translate that into a risk management process. So you identify the top risks that need to be handled. And in the final step here, what we have taken into account is the framework put forward by the Dutch government, the FREYA framework. And we prepared, and we are currently applying an ethics and legal analysis questionnaire based on the FREYA framework. So you can find more details about that. But the interest there is, what are the intended effects to the system, to assess that, So this is the why question. What kind of data is needed? What kind of algorithm? How the algorithm is implemented and used, and then there is an assessment of the extent to which any fundamental rights are impacted upon. Now, a final thing to share is that we asked also the ChatGPT of what could be its proposal for aligning AI with human values. And we got this kind of quite generic answer. It's hard to argue against it, but we found it not to be very practical or applicable. So the next question to ask was, can you offer me some more practical tips? And that has become a little bit more practical. So some tips about stakeholder engagement, communication that you can see also in our process here, which is about transparency management process. And some more tips about monitoring, testing, and evaluating, incorporating the values in the design process. So it is interesting. I think probably ChatGPT has taken into account these documents that we have taken into account because we work on this process. And the final thing to say is about the challenges for human AI synergies. Governance is a huge challenge, and it's not in the least resolved as we stand. So what is the provision for external oversight of an AI implementation and operation? Certification challenges, which should be huge, at least in the medical field, but not only. And then what kind of resources to be taken into account? What is the design process and how to operationalize AI at work environments? What are the knowledge bases that need to be consulted? So if you think about AI capabilities, we are all very familiar already with augmentation, but the true value of human AI synergies will be, we believe, in collaboration. And if you link that with human AI synergy goals, which is about not only understanding the world, but better organizing it or processing it, manipulating. When I say the world is the world environment, I don't necessarily mean the whole world, or create a better practical situation. So we talked a little bit about aspects of human in the AI loop. We talked about the motivation for human AI synergies, some practical examples and some challenges, and we look forward to continue working in that in the context of these three European projects I mentioned. But I think probably there is still some time for our discussion. I would like to thank you very much for attending this presentation. So over to our moderator for questions and discussion.
Thanks so much, Christos, for an excellent presentation. It was really insightful. I would like to invite the audience to reflect on this and raise any questions that you might have. From experience, sometimes it does take a moment before that message is actually written in chat. So in between, maybe Christos, again, thanks. It was really interesting. And I was wondering, because in some aspects you do refer to the healthcare domain. And I think, we are a highly regulated environment, and that makes us challenging for innovation. But on the same hand, we face the boundaries of what we can achieve with the current workforce. So we really need to augment our workforce with these new technologies. So I think we are a great place to start, or at least to perfect it, maybe. So who are your partners that you work with in the healthcare domain? Do you have current collaboration partners, and what type of activities do they do, and where do you see it being applied?
So thank you, Bart, for this question. So I would take the humble view that medicine is not really my domain. So I was very cautious in approaching that. I did try to offer some examples, but one of the things that I would expect both from humans, but even more from AI, is to know what they don't know. And sometimes we humans are not very good at that. We expand well beyond our reach. But it becomes really a problem with AI that often expands beyond its reach. So many of the AI systems that we currently use don't know what they don't know, and they're overeager to offer their outcomes even outside their domains. So we engage with active learning types of machine learning for this kind of situations, so that we have humans questioning the knowledge of AI and trying to test its limits, but also expand it. In the projects that I mentioned, one of the projects tries to work on the decision boundaries between humans and AI for the healthcare domain, but not in clinical context, but mostly in contexts which are about care for long-term patients, or for example, cancer patients, and assistance they might receive remotely at home. This is a project that has just started, so I cannot claim huge advances in that, but I'm very keen on interacting with the community as we progress in this. The challenges are very big. You mentioned regulation is quite important. Certification is quite important. So there are many cycles of consultation needed to receive, for example, scientific advice for what you do before even think about getting certified. And I'm sure that in your community that is quite recognizable. But some of the challenges that I mentioned, and particularly the limitations of AI, need to be acknowledged. We need AI, especially in the medical domain, that knows what it doesn't know, so that it can inform the human users accordingly.
It's a nice bridge, and thank you for the response, Christos. Of course, I assume that anyone here on the call has used ChatGPT in some way, shape, or form. And one of the disappointing things is that it doesn't tend to be quite transparent about the confidence that it has in its responses, right? It just gives you a response regardless of. But that's, of course, in our medical domain, a really, really different environment. So in the meantime, we actually have questions from the audience as well. So familiar name again, 𝐭𝐚. Very much welcome to the ecosystem again. Thanks for an interesting presentation, 𝐭𝐚, right? Although I see the benefit of having humans in the loop, developing such systems adds quite a layer of complexity. Do you have any pointers for developing systems with humans in the loop?
Thanks, 𝐭𝐚, and that's of course a very good question, because part of the motivation for employing AI is to make life easier, hopefully not as boring as the book that I mentioned implied, but simpler, and automate some tasks. However, humans bring in contextual knowledge and domain experience that is harder to encode in the right context in such systems. And if I would argue about integrating the human in the AI loop, I would argue in favor of integrating the human cognitive abilities that were mentioned in part of the presentation, if I can quickly find it. There are practical situations that this happens. There is research currently ongoing, even funded by DARPA in the United States, that has advanced a lot since the early days of situation awareness to try to work out this kind of cognitive coupling between humans and systems. A couple of the examples we mentioned exploit this kind of synergies to link human knowledge from the experience of humans to data. I can give you a practical example. Let's say that you take measurements from a situation, I can refer to the domain I know a little bit more, which is the engineering asset lifecycle management domain. You can have data from railway infrastructure, you can have data from production machines, but you don't easily integrate the context of this data into the system. Yes, you can tag the data, you can annotate it, it comes from that date, you bring in all sorts of other factors, but integrating all the contextual knowledge, the priorities into that, it's not so easy. Who is the priority customer in this case, and why? What do I plan to do in the future? Do I anticipate any disruption? When I got this kind of data, the measurements, can I link it with anything that the human operator observed on the shop floor? So there are such pointers, and there are such examples of technologies. I can mention at least two. So knowledge graphs is a very good example of how to link this kind of domain knowledge from humans in the loop with data. Ontologies is another example, but acting at a higher level. So I think we can benefit from that. So let's say that you get data from a measurement and it belongs to an abnormal situation. How do you label that? The AI will not label it automatically if the AI hasn't seen it before. And if a human is involved in the loop, its life, his life or her life will be much easier if access is offered to this domain knowledge. It's only one of possible 10-fold modes. It's only one of possible 100 human conditions in the case of a diagnosis. So that's my kind of incomplete, I acknowledge, feedback to your very good question.
Thank you, Christos. And for the sake of time, we should not do further questions, although I do want to say, Christos, that my colleague at Dash, Miriam Plantinga, puts a chat in. Sorry, my video does not seem to work, but very interesting talk, and I would love to talk further. She sees very many overlaps on her activities and challenges that she works with. So I'm quite sure that we will be able to connect you, and also for the others in the digital room. If you would like to connect further, then please make yourselves known either through Dash or perhaps directly with Christos. Then to conclude.
Can I just quickly say that
yes.
Absolutely to Miriam, the lessons learned from 𝐜𝐴 are relevant also, I believe, hugely for industry as well, which has to develop its own 𝐜𝐴 kind of initiatives and activities.
Right. Thanks, Christos, for the final remark. And with that, I want to close the meeting. Again, thank you so much, Christos, for sharing your activities, your knowledge, and activities. And I just already mentioned a QR code for everybody who wants to join our newsletter. And we look forward to future editions of the webinar. So thanks, and enjoy the rest of your afternoon.